Hi everyone, my name's Daniel and I'm a PhD student at the Smart Systems Group at Heriot-Watt University and University of Glasgow. I've recently graduated with a Master's in Electrical and Electronic Engineering. I'm going to be helping you all understand some of the jobs that robotics can complete in the future to help operate, maintain and repair offshore wind farms. The topic of discussion today is robotic engineering superheroes and robotics in the danger zone. Now, some of you may think of robots such as the following animations here. And when we think of superheroes, I personally think of the Avengers. This includes Iron Man, the Hulk, and Black Widow. Who hasn't dreamt of shooting webs, lifting up cars, and flying high in the sky like a superhero Avenger? Of course, these are crazy things in our imagination or what we see in movies. However, robotics is making some of these things a reality to make jobs easier and more efficient for humans. Some of the robots that I'm going to talk about today include the Spot robot, our UAV telodrones, and then the Husky robotic platform. So, what do I mean by offshore wind farms and operation and maintenance? Offshore wind farms harness energy from wind, which can be used to create green electricity for us to use, whether it is powering electric cars or even the laptop which you are watching this presentation on today. However, wind turbines need maintenance to keep them in tip-top shape so that they can perform well and are efficient at converting wind energy into electrical power. This is where robots come in. So, going through this robots in the danger zone for wind turbines, the wind turbines are used to produce energy, but did you know that they can be quite dangerous to maintain? So, we've got some dangers such as foundations cracking, as you can see here, a motor failure, we can see smoke coming off the wind turbine here, and then also some dangers for the different robots that are there, before the robots, for the humans that are on the wind turbine blades, because sometimes we need humans to go offshore and check for cracks or check for motor failures. So this can be dangerous for repair and maintenance operations. As we can see here, we've got Jack holding on to what looks to be the tower of the wind turbine blade, and there's gusts of wind, so that's quite difficult. So fixing these issues is no walk in the park either. For example, you have to work underwater to repair the foundations where you face the dangers of poor visibility and unpredictable currents. We can see the currents as Jack's holding on here. So Jack's saying, "It's dangerous this deep beneath the surface. I can barely see what needs fixing." So, moving on, humans aren't designed to maintain wind turbines, and so it's dangerous for them. But these robots and software are specifically designed for the job. We've got a UAV here, we've got some sort of snake robot, we've got some limpet robots, keeping an eye on things, and then we've got a computer. And the computer is used to help control and understand what the other robots are doing. So, when checking for damage on a wind turbine blade and repairing any can be tricky for a human. So what we've got here is a drone flying along the blade and scanning for any possible damage. So, in current procedures, a human is actually deployed on a wind turbine blade when the wind turbine blade is stopped to detect, to see if they can inspect for any failures on the wind turbine blade. And what we've got here is a drone flying up with a toolbox for the human. Might be a drill or a hammer or something that they might need, or even some materials for repair. What we're seeing here is this snake robot called Ivor 3 is used to scan the underwater foundations for damage, and in doing so he can plant limpet robots. So that's what we're seeing, these limpets are the blue ones here on the foundations of the wind turbine blade. So, the limpet robots can sit alongside actual limpets and monitor the structure. The great thing about offshore kind of wind farms, albeit at the start the kind of wildlife goes away because all the noise, but then eventually the wildlife starts to come back, and then the wind turbines become its habitat as well. So the limpets can also be placed on the surface of the structure by the drones. So we're seeing the drones positioning them on. So how does Jack control all of these robots? And we can do this via the computer, and the computer is called Miriam. So all the while, Miriam can collect information from the different robots when queried by a human. Miriam speaks all the robotic languages and can talk to any operator using a human language too. So the thing about robotics, similar to humans speak English, French, Spanish, German, and the list goes on. So robots also have similar kind of languages that they speak as well. So they've got Python, for example, C++, what else have we got? Robotic operating software, so ROS is another language as well. So what's Jack saying? How does the drone's operations go, Miriam? And Miriam's saying it's going well. The drones are nearly finished applying the limpets. So with their help, us wind turbines can continue to be awesome without putting human lives at risk. But none of the robots are allowed to work before their V&V, validation and verification, to make sure they're working properly before being deployed. And the reason we want to send the robots out is to make sure that the wind turbine blades are operating efficiently and effectively, so that we can convert that wind energy as efficiently as possible into electricity for us to use. So what are some of the challenges within the offshore sector? So at the top left, we've got transport and logistics of engineers. This can be costly, time consuming and expensive. Often crews live on large transfer vessels. At the top right, we've got risks to safety. As you can see at the top right, working at sea can be very dangerous. This can cause problems for people transferring between vessels or completing work offshore. Operation and maintenance, time and costs. This includes people inspecting the offshore wind turbine blade here. So sometimes the weather conditions can change drastically, and this can be difficult for offshore wind farms. This can mean that sometimes an inspection might need to be postponed. And as you can see here at the top right, where the waves are crashing really large, that is some of the difficult and hazardous weather conditions that these offshore engineers like this guy here has got to put up with. Even here you can see the water's quite dangerous if this person didn't have the correct tools and safety to keep him safe, you know. And then at the bottom right, we've got a recruitment shortage. So job roles have changed, where many now prefer to live and work closer to home. However, many opportunities exist offshore to see the world and many places. So, we live in a time where robotics can respond to problems which occur daily in the world we live in. Technologies including global communication networks and monitoring technologies and electricals are allowing us to connect with communities, environments and industries. One way we do this, and this is my research that I'm completing, is creating a symbiotic system of systems approach, where robots and sensors can communicate together to assist with problems that other robots face. This also allows for humans to have an increased operational overview of where these robots are being sent to when they're very far offshore. What we're seeing right now is our Blue Rov subsea vehicle completing an inspection underwater. We've also got Husky on the left here, where the runtime reliability ontology can detect to see if Husky is operating as intended. An example that I would use is if I was to break my arm, I would just say, I can't work today, I'm broken. But how does a robot communicate that to a person to say, my universal robot manipulator arm isn't actually working today? So that's one of the challenges that we've got. What we're seeing here is we've got a virtual reality kind of headset to view different diagnostic information, and then the ghosting function where we can control different raster scans that are going on here, from the robotic arms. So what we're going to see just now is our Boston Dynamics Spot robot, and we are just teleoperating this robot around the room. This was one of the first times that we got it, so it was pretty exciting. Basically what we're doing is just as you would a kind of remote control car with a controller, using a sort of the controller that comes with it, let's say an Xbox controller for example, and driving the robot about. The same with this one here, with the Husky robot. That's got its own type of controller there. So here what we're seeing is we're using these DJI telodrones, which are UAVs, to fly the robot around the Spot robot here. And what these UAVs have on them are small cameras, and what you're seeing right now is the footage captured by the telodrones, and we can see that this footage is actually quite high quality considering that these are quite cheap drones. So that's pretty excellent. Now, one of the things that I'm tasked with in my research is multi-robot fleets. So the question is, how can these robots all communicate together to reach a common goal? So helping each other out to complete a mission. And then what we're quickly going to go through here is a brief example of where you may see different robots offshore. And what I'm going to do is in the next slide, I'll go into this in more detail. Alright, so these are quick examples of an offshore substation and how that looks. And the key thing that ties all these together is the bidirectional communications between all the robots and human in the loop. So, what does current and future offshore deployments look like? So basically what we've got here is a current offshore wind farm on the top left and a future offshore wind farm on the right. Now, as we move through these slides, what we're seeing is on the left hand side here is an offshore substation, and on the right we've got a heavy crew transfer vessel with a helicopter that could be deploying people. Now, there's a lot of challenges with this, and we've got weather dependent deployment. It looks like a nice day now, but it might be the weather can drastically change, especially where I'm based in Scotland. It is also expensive to deploy people offshore. So, and then another thing as well is some of these vessels emit a lot of carbon emissions. So if we can change to use batteries or lower carbon kind of transport, then that's going to be more effective. So one of the things that I'm working on is resident robots. So that's robots that live, operate and charge offshore. So what we're seeing is an autonomous surface vessel deploying a UAV for inspection, and this doesn't have any people on it. We see here a UAV and the Spot robot on an offshore substation, and they're completing different inspections. And then we've got the Blue Rov, as you've seen earlier, and then a Hugin Subsea vehicle. So the roadmap here that we're kind of getting is to increase safety and reduce risks, which then leads to resident robots, bidirectional communications, and many other advantages. So what we're seeing here is the Husky, the dual UR5 Husky robot. We're going through some of the sensors that we've got on this platform. So this includes a 2D LiDAR at the bottom left, and a LiDAR is essentially a laser So this is many lasers get scanned out across the room from around this circle, and that builds up a navigation picture for the robot. And that what we've got is we've got a LiDAR positioned down low to detect any low obstacles, and a LiDAR positioned up high to detect high obstacles. Now the difference between the 3D and the 2D LiDAR, this one just does a kind of sheet scan, whereas this one, the lasers kind of come out at an angle to detect the room. So we're actually getting more information from this LiDAR. And then we combine both pictures to create a nice image for the navigational systems. We've also got the robotic manipulator arms, which you're seeing kind of out positioned here. We've also got another sensor on, which is a radar mounted on this pan tilt unit, and the pan tilt unit is the gold kind of cameras here with the eyes, and then on here the black box is the FMCW sensor, and that's the same sensor that's positioned here. Now, one of the other things, what I'm going to do is I'm going to show you guys our Robot Myths TikTok page, and this has lots of videos on it, so if you're on break or lunch or outside of school, feel free to search at robot_myths to have a look at this TikTok page.
Ever wondered why Husky has robot arms? We can use them to position the sensor which the gripper is holding currently. Safety is priority, so we need to be super careful.
So that just kind of shows some of what the Husky robot can do there. So moving forward, we've got the Spot robot as well. Now this robot is a really agile robotic platform, which is great because, for example, the Husky's got wheels, so that Husky can't actually go upstairs, whereas this robot is really effective in kind of tight and narrow areas. So we've got quite a long runtime there, about 90 minutes, and then also we can see the robot going up a hill just now, and this has got lots of different obstacles on the surface. The robot can go down steps, which is a great advantage, and can detect different obstacles in the way for obstacle avoidance. It's easy to swap out the battery of this robot, which is a great thing as well. And even now there's different applications like wireless charging, which you can include on these robots. With the robot, you've got the robotic arm, and then potential for different payloads, and can even carry up to 14 kilograms. So as you can see, that is a great example of maybe things that the robot could carry, or different payloads that the robot can have on. Now, what you're going to see in a second, and one thing that's really important, these robots are operating in difficult environments. So I think that was -20 to about 45 degrees Celsius, and can operate in rain and dust. And this becomes really important when robots are operating outside. Obviously, Scottish weather isn't the best. It's not like as pictured just now. So these things can drastically change. Now, kind of moving forward, this is where the human in the loop is on his computer typing away and can program the robots to do lots of different things. And this allows the human to focus on really difficult jobs. So as the human's away off to do now. So moving back to our kind of robot TikTok page, at robot_myths, what I'm going to do is show you another video that we've created for the Spot robot. And what we did here is, because the robot's got 4 legs, it's got lots of balance algorithms on it to be able to make sure that it can keep balance and stay standing. So what we did was we gave it a wee push with our foot to see those kind of balancing, reacting in person. So I'll show you the video and then I'll describe some things afterwards. So what we did in this video was around about here, one of our colleagues gave it a small push to see the balance, and what Spot does is it uses its balance algorithms to move to the side, and you can see it putting its legs back into position to get its balance again. And then the reason why we named the Spot robot Martina, and I know my head's kind of blocking it off a little bit here, but it's basically an acronym. So mechanical, artificial, remote, technological, intelligent, ninja, arm. And that's because this robot's got the manipulator arm on it, as you can see. So, kind of moving forward, we did recently an autonomous mission evaluation where this is the map that gets built up from the different LiDARs here. So we can position different waypoints, which were the green dots there. And this, where you can see the FMCW sensor scanning on the metal sheet to detect if there's any corrosion. Now, this area here for Husky is classed as a confined space area. It's really difficult for Husky to navigate straight through this area because it's quite tight. And then what we've classed this area in the back here is an area which is really hazardous to humans. So it could potentially have a lot of radiation in it. There could be a fire. There may be some gas out there. And what we're seeing again is the runtime reliability ontology, which is making sure that the robot is operating effectively, and the FMCW radar data where you see here, this is scanning the metal, in fact here it is now, scanning the metal sheet for any corrosion. And what we can do with that is send the robot in to detect in advance if there's any corrosion. So do we need to get rid of that corrosion to make sure that the plant operates as intended? What you're seeing now is we can control the robotic manipulator arms here to make sure that they are operating as intended. Now I'm going to put this video back a little bit. What we can do is we can slide about using these sliders of the different arms. Now, if I was to reach for this whiteboard pen that I've got in front of me, what I would do, as you would, is just reach forward and kind of grab the pen, alright? Now, but one of the challenges we've got with robots is sometimes a robot thinks it's more efficient to kind of reach in but do a really weird move that might be unpredictable and then pick up the arm, the pen. Now that's pretty unsafe if we've got humans working around it, or it might be unsafe to the plant. So what we can do with this is use the sliders to make sure that the robot arm acts as intended. Now, one thing at Heriot Watt that we've got is we've got a decommissioned blade. Now this is actually quite a small decommissioned blade, and that's due to it being quite old. The kind of wind industry, wind turbine blade industry has advanced a lot over the years. So, for example, recently I was down south in England inspecting a really large wind turbine blade, which is probably a lot longer than the house I'm in at the minute, to be honest. So you can imagine, maybe even longer than, in fact, yeah, definitely longer than any classroom I've seen for sure. And what we're seeing now is one thing that's really important is PPE, personal protective equipment. So humans wearing helmets and high visibility around the robots to make sure that everyone can be safe operating around these different robots. So, moving into this next slide, we're going to discuss the asset integrity dashboard. So here's a view of this offshore of this wind turbine blade, which has been decommissioned. And what we did was we've created a lot of different defects within that. So we've drilled holes into it, as you can see here. We've scraped it. We've scraped away areas here and here just to double check to see if we can use the FMCW radar to detect any defects. Now, why would we want to do this? And the reason for this is due to, basically, we want the wind turbine blades to operate as efficiently and effectively as possible. All right, and one thing that really can degrade the efficiencies is different scratches or different defects. Now, offshore, in hazardous environments for wind turbine blades, they're going to be under, some might have a lightning strike, which is quite common. You may also have wind erosion, which might cause different scratches, and then all these things need repaired to ensure the optimal kind of efficiency of these wind turbine blades. So what we're going to see in a second is we created a delamination, is what it's called. So this gap along here that you're going to see is classed as a defect on a wind turbine blade. And what we did was we scanned the healthy side, so this side. We then scanned this side, and then we also dropped 3 millilitres of water into this gap here. Now, around about this area here was where we scanned the blade. And what the FMCW radar is good at is detecting surface and subsurface defects. And that improves what people can do at the minute. Because at the minute, if you were scanning this area of the wind turbine blade, you would only see the outside using a camera. But using the FMCW sensor, you've got increased kind of view of what is going on inside the blade as well. Now, we've got a tiered leveled approach where you can see graphs, you can see descriptions, and what we do in the next kind of tier is a direct description of what is going on in this kind of graph. Now, what we're seeing, once this zooms in, the blue line here, is where you've got a healthy baseline signal. And that's what we take all of our readings from. On the bottom, you've got the delamination. So we're getting a different return from the radar here. So the signal's getting sent out, it's bouncing off the decommissioned blade, and it's reflecting back. And when we added water at 3 minutes and 40 seconds, 3 millilitres only, we can see the signal's gone right up and then levelled off at this area around here. So that's really useful information for us to know about, because now we know, right, there might be a problem on our blade and we need to go and inspect it to make sure that the blade's operating okay. Because if one of the blades breaks, that could be a catastrophic failure, which might cost a lot of money. It might also jeopardise kind of risks for humans as well that might be operating next to the wind turbine blade. And then it can also have a huge detrimental effect for the environment as well. So, in conclusion, robotic superheroes can be used to make life easier for humans completing work in hazardous environments. This can save time and increase safety for any engineers who are usually deployed offshore. We often use problem solving to create these types of robots and ensure they can operate properly to complete the tasks we want them to do. Now, if you're going to be creating some sort of research project potentially in the future, some ideas might consist of safety between robots and people. What types of robotic platforms are out there? And the type of jobs which robots can do. Now, following on from this, if you want to, during kind of out of class hours, feel free to have a look at the Robot Myths TikTok page, because there's lots of videos on there of other robots that I've not even spoke about today, purely because I've not got enough time. Alright. Now, one other thing that we wanted to do was, just in case you're considering a career in engineering or robotics perhaps, is kind of discuss the different reasons why you might want to discuss that, to do that. So some courses you might want to consider are computer science. And sometimes you get computer science with artificial intelligence, or computer science with games programming, and other kind of subjects. You've also got electronic and software engineering, electrical and electronic engineering, which is the course that I did, software engineering, and robotics, automation and interactive systems, down the bottom here. Now, if you are in Scotland, then you will need a Highers with an A and 3 Bs, and it must include mathematics and plus physics, technological studies or engineering sciences at a B. If you're doing A levels, you will need a B and 2 Cs, 2 3 Bs, including maths and physics with 1 at B. For IB29, mathematics and physics at higher level 5, BTEC, DMM in relevant subject, and HNC an A in graded unit in relevant HNC with additional mathematics. Now, mathematics is important for coding and programming and in engineering science, but does not necessarily need to be physics. Just to note as well that these entry requirements are subject to change, so please look online at your preferred university and course, just to make sure ahead of when you're doing all of your exams and stuff, alright? Better to be safe than sorry. So, 5 reasons to study computer science at university. Technology has made the world better, faster, and more connected. Take your passion for technology and use it to create gadgets and computer programs which help us every single day. Computer science graduates are in high demand across many sectors, meaning you can work in any sector you want, whether that's nuclear, transport, energy, offshore, lots of different kind of examples there. It's really rewarding working in computer science. The constant development of new technologies means that there's a constant demand for brilliant tech minds. Some of the things that I've learned from lots of problem solving is once you get something working, it's one of the best feelings in the world as well. So having a computing degree will provide you with the knowledge, problem solving skills and analytical thinking capabilities that serve as a competitive advantage in your career. This also includes internationally diverse with the opportunity to work abroad, because a lot of these skills are transferable abroad as well, so that's great. So some different jobs that you might want to consider. Artificial intelligence. This has been named a key driver of the 4th Industrial Revolution, and some would argue that the 4th Industrial Revolution is even happening as we speak. We have experienced AI in our homes, in cars, in farms and agriculture, in business and even public spaces. And a lot of AI uses machine learning to learn the data. And sometimes the way that I think about AI is if we were to problem solve in our own brains, sometimes AI can figure things out a lot faster. And then some job titles include machine learning engineer, data scientist, and AI researcher. There's robotics titles as well. So robotics is a growing field. You've got mobile robots, as you can see kind of going on with Spot and Husky in the drone now, but you've also got large robotic manipulator arms, lots of different other robots. So this can include from building cars, supporting agriculture, and even assisting in surgery. So a foundation in computer science equips you to program the software that helps physical and virtual bots operate more effectively. Some robotics titles include robotics engineer, technician, software developer, and robotics are mainly used for the 5 Ds of robotization. So robots can complete dirty, dull, dangerous, difficult, and dear jobs. So also a website designer. You can create and code web pages using both technical and non-technical skills to produce websites that fit your customers' requirements. So this could be the code in the background, or even how a website looks. There's lots of different roles that you can have here. So different the job titles are web designer or web developer are the main ones for those. So a games programmer. What we've got here is someone wearing a virtual reality headset and kind of touching things in that virtual reality space. So for a games developer, you can create, develop, and program the different codes for whether it's arcade games, PlayStation, Xbox, tablets, apps. As games get more advanced, gaming companies need more skilled people for designing and programming different games, whether it's via control, virtual reality, game physics, networks, and user interfaces. So a games developer might be deciding on game story and how the game plays. A programmer codes the games using the languages so that it all works together, and you've also got technical support specialists. As a software engineer, you may find yourself working in a variety of industries. You'll need to create, maintain, test, and improve systems. This is an a kind of role with many opportunities in a wide variety of sectors as well. Finance, films, games, pharmaceuticals, agriculture and healthcare. Virtually all areas of business and society, because so much software is becoming more easily available via our phones, via computers, lots of things there as well. So even computer forensics. Computer forensics exists at the intersection of law and computer science. I don't know if anyone's ever watched 24 Hours in Police Custody, but the example I think of is when a phone gets confiscated with evidence on it, and you can plug in and take data from that phone. So this is where the recovery of digital evidence recovered from computers, networks and digital storage devices that can be taken into a crime lab where law enforcement can act as a contractor there or as a private contractor. And different computer forensics job titles include digital forensics specialist, computer forensics investigator and forensic computer analyst. And then lastly, cybersecurity. Cyber attacks rank among the fastest growing crimes, fueling a global demand for cybersecurity skills. Again, when all of the kind of software comes together in our phones, there's so much of our data going online at the minute, going to the cloud. So data breaches are a kind of a difficult thing at the minute. So we need to help protect the data from any criminal activity. And this is a job, this is some stuff that I'm researching right now at the minute, to make sure that the kind of communications between robots are secure and no one can take over different robots as well. And that marks the end of the presentation, everyone. So as a final note, I would like to thank you all for watching this presentation and wish you all the best of luck with any future exams. Always keep in mind that hard work beats talent, so keep sticking in when it comes to any schoolwork or things that you enjoy. If you're a teacher and have found this video useful, please reach out to let me know via LinkedIn, which is displayed at the bottom left of this slide. Any feedback is very useful. Thank you.